Hi everyone, welcome back again to my channel. This is part 4 of the DIY A320 Neo home cockpit build process. We're going to focus on the main instrument panel, which is the front panel, where there's several monitors or display like the primary flight display or PFD, navigation display, ECAM, upper and lower, and of course the standby instrument, which is ISIS. This main panels is much simpler, so probably it's going to be quick, but we're going to go through a bit more details in the build process. So if you can see here, there's several elements in the MIP. We are not going to touch the FCU, so the FCU and FS is the upper section of the front cockpit, but we're gonna focus on the bottom part, which is this center panels. They call it the main instrument panel, where we have two display, which actually served by one monitors. It's actually 19-inch LED HDMI monitor, and the second display actually ECAM upper and lower, and also ISIS together, so the monitor is this big, covered by 22-inch LED HDMI monitors. And also in this panel, I don't build everything. So for example, this chrono and clock or timer modules, actually I got it from opencockpits.org. Unfortunately, it cannot be connected because they have to use their own software to connect. I think to P3D or to explain, I think they could, but not to FS2020. So unfortunately, I cannot use this one. So it's light up, but it won't work. Okay, and the second item that I bought actually is the disc brake gauge. I bought it actually from Custom Sim Parts, but actually is not. It's actually without the driver, so it's just the servo motors, unconnected, 3 servo motors and the backlight. So the backlight I can connect. The servo motors later actually I connect into Arduino directly and program it through MobiFlight. So it's working now, this gauge, but it's quite noisy, the servo. Anyway, but it's working. Also, the other one actually I bought is this rudder. Okay, I put rudder in the main panel discussion just for the sake of the discussions. Okay, so just for the sake of the discussion, I put rudder, which is from MFG Crosswind, rudder pedal with a custom footrest or foot stand for A320. So this is a 3D print footrest. The footrest actually in the center footrest, actually I created also my own, so the DIY. The rest actually DIY, including the panel itself. This one, this left console panel is also DIY. This ISIS or standby instrument buttons also DIY. This panels of landing gear indicators and auto brake is also DIY. The landing gear lever also DIY. I used the old one that I used previously in the multi cockpit so it's gated, so you have to pull first and then move up or move down, so it's good. Yeah, also the T-Rain, of course Corey switch is DIY, and the drawer, retractable drawer, I put a keyboard inside here, also DIY. So we're going to take a look later on this part in more details. So before we go further, as mentioned, this is just a list of the item that is, which one is DIY, which one is actually bought. So mostly the monitors. I also I modded the monitors. Later I'm going to tell you that the backlit of the monitors, so the brightness of the monitors, I manually control through a PWM circuit, through a potentiometer. So the potentiometer for the ECAM and potentiometer for the PFD and D are together tied together because it's a single monitors. But I can control directly from the cockpit, so I don't need to create applications or what the application don't need to read the potentiometer position or and then inform the dimmer. So it's directly to the dimmer, controlling the PWM of the monitors. So usually monitor have a up and down button, but you have to go to the menus first. You cannot directly control the brightness up out of the from the front of the monitor button, for example. These day monitors are quite complicated, so it goes to menus. So to control the dimming of the or the brightness of the monitors, I cut the backlight positive signals and run through a PWM circuit to control the brightness. So that's the only changes for both monitors. So the eCam upper and lower have one control of the dimming or brightness, and PFD and ND one control of brightness also. So that's the only modification that I did for the monitor. So it's kind of semi DIY, I guess, because you bought a monitor, but I take down all the parts and just and modified the monitors. The chrono, unfortunately, I haven't really drilled down into the chrono. It's very nice, good looking, white 7 segments, so it's very original but looking, but unfortunately I cannot interface it with MobiFlight. A320 brake gauge, as I mentioned, is working very fine, and crosswind rudder also working very fine, very well. So that's the components. And looking at the design, I would like to show you first, of course, from SketchUp. Here is SketchUp design of the main panels. So you can see panels created ready for expansion. So you can copy this one and mirror it, and then you have the officer side, first officer side, but in this case, I just created half cockpit, meaning that the central console created, but the captain sides only that we fully built. Okay, so here you can see there is this. This consists of three section, which is this left console with the speaker, and then this captain side console with the some brightness control for the PFD ND buttons, lights for the left console and foot area. This one here are also being provided and working, and also this two display surface by 119-inch monitors behind it. The third panel is actually the central panel, which is the eCam panels, we call it, because there's hosting two eCam upper lower, which is served by 122-inch monitor. Initially, I planned for 24-inch monitor, but I found a monitor that 22-inch, but it can cover the width of this distance from covering the ISIS, the standby instrument, also the eCam. Last time the 24 able to do that, but it's kind of protruding quite long, so actually to the lower section rather than to the upper section. This one is not adjusted yet, and that's also for the landing gear indicators. This one is for chrono, this one is for brake gauge, and this one is for landing gear. So this one is a simple panel. I'll show you later on. This one is also retractable drawer. It's not updated with the latest design that I've created for the actual build, but the plan is really to be able to pull the drawer out and put a keyboard inside in case I need to access the PC, and also with the touchpad with a wireless keyboard something. So this is not yet updated on the drawing, but the actual build actually already kind of tried to. So I built on the fly rather than from the drawing. So unfortunately, I didn't update the drawing. So as I mentioned, there is three main structure here, which attached with several spar. So this is the left portion, the higher one for the center, and then for the right section. So this one is for attaching the FCU and FS bottom plate here, screwed up to these structures. So then we can put the FCU and FS on top of it. So I have covered this area with cover, the 6mm plywood, laminated plywood, and also for this one with thicker one, which is a 18mm plywood, just to put a base here, and then also cover this again with 6mm plywood or MDF panel, so to close the whole things, to close the whole sections. Okay, so this one is sit on top of the, as you can see, the floor. It's the floor here. So on top of the platform, and bolted down with the bracket here. Yeah, so it's sturdy enough to be used as the main structure for the MIP, or main instrument panel. Okay, so the monitor is sit behind the panels, and the panels actually is quite thick. I'll show you later on the build. It consists of I think 3mm plus the 6mm of MDF panels. So it's combined. It's kind of sandwiched together. So it's kind of providing a very sturdy. I think it's 2mm panels. I've got triple 2mm sandwiched together, plus the 6mm MDF panel behind it. Okay, so I think it's very sturdy, very. So why I put the acrylic up front as a front face? So it's very smooth compared to MDF. You have to make sure to finish well, because if not, then you're gonna have a very rough surface. But with acrylic in front, glued on top of MDF, you are guaranteed to have a very smooth surface in the front area. So yeah, so that's how I got the front area smooth finished. On the left side, you can see there's this one is unfinished, but I have the finished versions in the Coreldraw also. So you can cut the whole of the speaker cover. So it's kind of following the original design of the speaker cover of the A320. Okay, and also I put some feature fake AC outlet over there. So this is the initial design. So the final one is definitely a lot of changes, but I didn't update it. I'm quite lazy enough to update the design in SketchUp. Okay, so the second design that I'm going to show you is of course, the Coreldraw. So you can see here the design of the speaker is here. You can copy and then laser cut the 2mm acrylic and paint it blue gray, and then it will looks like the real cover. This one is for the hole for the fake AC outlet, and this one is several layer. So bottom layer 2mm, bottom layer bottom layer is 3mm, top layer is 3mm. So two 3mm sandwich together. Okay, so it's not 3 layers. Sorry, I forgot. So it's basically is intersection. So the bottom part is longer than the top one. So it's kind of intersect each other, crossing each other. So it's kind of when it's glued, it's kind of having a better bind rather than you so it provides a stronger sandwich. So the 3mm on top and 3mm below have a different kind of length here. So it's kind of glued over here in this area. Okay, so because I cannot cut larger than 40 centimeters or 35 centimeters, so I split into two cutting in the acrylic, then join this butt join with the glue for those two panels. So 6mm plus 6mm MDF panel, so total 1.2 centimeters or 12 millimeters thick panels overall for these panels. Okay, similar here, I cut into 4 sections of these panels, 4 section cut into the laser cutting machine, and then butt join by acrylic glue here, and after that here also, and after that I attach it to MDF, and of course I've already cut the hole over there for the MDF and smoothed up the finished S1 piece. So this one is one section, this one big section of the center panel, another big section here on the captain side, and another big section here on the left. So smaller section actually. So this is how I do it in Coreldraw, and acrylic face front facing plate with the MDF behind it. Okay, so MDF you just pattern it and then cut through jigsaw or some your cutting tools that you prefer, and smoothen out the back part, the 6 millimeters, and then glue the acrylic into the MDF using power glue also, because it's quite nice. And also you can put some bolt later on just to secure it further. So this is the design in Coreldraw. Let's go into the some photos that you can see it how it looks in the actual build. Okay, so this one is the panel that has been cut but not yet glued. So those 3 millimeters on top of each other. So the bottom part is longer than the top part. So it's kind of crossing each other in the section. So when it's glued, it's stronger. And also after that, we put on top of the MDF, 6 millimeter MDF anyway. So it's going to be, so not 3 layers. So it's going to be 2 layers. So I correct in this video. So 2 layer of 3 millimeters plus 1 6 millimeters layer. So this one is for the captain side. This one is for the ECAM panels. And once it is glued, it is painted with blue gray together, so it forms like this quite thick panel. So you cannot see the seam anymore, the glue between the 6 millimeter acrylic and 6 millimeters MDF. So yeah, so it's kind of already becoming one big items. Very sturdy, very stiff, with a smooth finish of acrylic in front. So this one showing the frame in the using the kind of not the plywood, but it's kind of like jointed wood panels. So it's less less strength than the plywood, but it's much cheaper and easier to work with. And because it's not heavy bearing structure, so I'm okay with this kind of plywood. So several spar just to attach this panel using L shape bracket from this panel to the structures. Yeah, so it's kind of sit tightly in this kind of, this is a test fitting for the main structures. And you can see here, this is from the front looks. There's a gap here to put the bottom part of the FCU cover. So this is the bottom cover of the for the FCU panel. This is already painted and several panels already installed just for test fit, including the panel for the front panel for the landing gear is fully light up. This one is for the landing gear status lamp, and then the auto brake and anti-skid and terrain on ND switch, and also here, and also for the ISIS. This one for the chrono. Back then I haven't really bought it, so I thought I would just cover it first with a blank panel so I can open it. So after that, after I bought it, actually I pull out this panel and replace it with chrono panels. Okay, so including also the brake gouge, and also, yeah, that's it. And this one, and for the this one is for the, I forgot the name. This one for the communication device, they put it blank. So this one for the other side. So this captain panel is also already installed. So this one is the panel that I'm gonna be put it here. The volumes, the brightness control here. This one is also made by MDF, painted, and kind of putting a putty just to smoothen up the surface. Some of this is like angled edges here, actually created by 3D printing. So I it's kind of hybrid structures. So it's kind of using 3D printing for this angled bevel here, beveled edges of the monitors. I created using 3D print and then glue it up together and then repaint. Put it a lot of putty there and sand it smooth and then paint it. Similar here, there's some bevel edges, bevel edge bevel here. Also print 3D printing and then glue it up. Okay, but this thing is created by using the MDF, 12mm MDF. Or 9, I forgot. Yeah, 9, I think. So another look. This one is a test fit with the monitors inside. So this is still using the old monitor, my Samsung 19-inch monitors. After that is broken actually, so I have to replace it with cheap Taiwanese monitors called SPC here in my country. So it's kind of like you can put any 19-inch monitors, I guess, basically. So what I did actually, I pull out all the cover of the monitor, just bare bone LCD panels with the bracket, of course, with the metal bracket. It's metal bracket. It's you have to keep the metal bracket because it's going to be needed to strengthening the whole structure. But the plastic cover, the whole plastic cover has been removed. Similar here, so I removed the plastic cover, so just the bare bone LCD panels or LED panels. Here you can see it shows in the ISIS or the standby instrument and the lower upper and lower ECAM, and then protruding to the lower part of the panels. So it's okay because it's well covered by the pedestal. This one is using the bot module from opencockpit.org, and this one is also DIY for myself. So rudder already put just to test with the width of the rudder. So it's quite wide actually on the rudder from MFG crosswind. Yeah. And this one is already kind of more finished with the FCU panels, the bottom part already installed. And yeah, it's been tidied up, cleaned up. All the instrument has been put in place, except for the brake gouge hasn't arrived actually from Italy. I'm not saying, or from US. The retractable drawer has been finished, so it can be pushed and pull out. I'm using a drawer rail, like a kitchen drawer or office drawer. Those are in the center here with the spar or the structures to ensure that if you push this drawer and then it will spring open and then you can retract the drawer outside, just like a drawer in the cabinet. Okay, so this is the main structure of the MIP. I put the cell call number or the ID of the aircraft as what do you call it, customized plate, so you can pull the plate out and replace it with new number if you want to, but I just use the fly-by-wire coding here or for the cell call and for the aircraft code. Okay, you can see here is actually just half of the left one, so you can put another right or the first officer panels in case if you want to expand this. From behind you can see there's a monitors has been dismantled, the cover, so the circuit has to be glued into the back of the panel using acrylic base, so it's not short circuit, so to just protect the back of the PCB touching the metal part of the panels, because the LCD panels, the LED panels, LED monitor panels behind the panels actually using a metal cover, so if you just put it there you might risk short circuit of the board. It's quite high voltage here. It's using 48 volt DC for brightness here, and then for 19 inch I think it's 35 volt DC for the for powering the LED backlight. So both of them has been cut when I integrate the installations and put through a dimmer, that the potentiometer of the dimmer I put it in the ECAM dimmer, and PFD ND dimmer. So just one of them that I use to control the brightness of this monitor. So I can control the brightness directly from potentiometer rather than from the menu or from the push button in the monitor, which is I put it somewhere to hit it, because in case I need to turn it off or turn it on again to reset the TV, I can reach it out. I put it under this hidden under this area actually, so you might not be able to see it immediately. So it's quite covered. So this is the structure after I painted with RAL 7031 color or blue gray color. And also this is the metal frame for the front bracket and to the window bracket over here. So this is another view on the center monitors, the 22-inch monitors. This is the module for the chrono, can be seen here, and for the brake it hasn't been installed yet. So this is open area, so you can I put a lot of electronic here, the power supply, the power outlet, and all the relay, everything, just to give control to these monitors. By the way, the brightness of the monitors also put through a relay circuit. So if it's cold and dark and the power, the external power is off, and the battery is off, it will immediately kill the relay for the whole power of the brightness of the TV. So it will shut off the TV, even the eCam, the MacDo display also. I put it there. FCU display, FCU backlit color, light also being turned off by the relay. So the relay basically function as the master switch or for the aircraft. So once you turn on the external power, it will bring up all the monitors backlit again, and several other area like the backlit panels. So it will switch on the main power supply, basically the 12-volt main power supply for the backlit and for controlling the backlit of the monitor also. So I created that circuit to simulate the cold and dark sequence. Sometimes in the simulator like this, you cannot do a cold and dark setup because well, it's just too cumbersome to do it. So I simulate the cold and dark by using a master relay to turn off all the power supply related to the lighting, except for the lighting of the FCU. Unfortunately, because I bought the FCU panel from Java Simulator, so I already look inside it. I cannot find how to terminate the lighting to the display, the 7-segment display of the FCU. So I cannot turn it off, unfortunately, but the backlit of the FCU, I can turn it off. The rest, I can turn it off and control. So basically, you found a dark cockpit during cold and dark setup. So it's good. So when you press the external power, it will light up everything. So this one is showing the rudder position tested with some bolt nuts and bolt to tighten it up to the bottom part of the cockpit floor. And also I simulate the skid plate for your swoosh for your feet. So it's using aluminum 2mm thickness aluminum, and brush it off with some sandpaper just to make it a bit gritty looks. Okay, so this one is the unit of the chrono UTC clock module from Open Cockpit. Yeah, so I cannot connect it to FSU IPC7 without doing some programming, but this is very nice modules. So unfortunately, I cannot interface it currently to the MobiFlight or to the FS2020. So this one is after cabling. It's look messy. I haven't really tidied up in this stage. So, but it looks not far from here, but just tidying up, cable ties it together just to ensure not easily pull out by any chances. But it is quite messy. So I put a acrylic plate here, a clear one, just to put several circuit board. This is the main relay that control the the power unit here. So this one is for lighting. So if cold and dark setup, external power is not in, this one is not activated. So you cannot turn on the light inside the aircraft, and also the display, the monitors going to be darkened because the relay is not up. So once it's powered, so it will power up this power supply, and the lights and everything can be light up, switch on. Okay, this is the main USB hub, so it's already going to be full later on, fully utilized. And there's several hub again, USB hub again on the overhead. So one USB hub on the overhead section, and one actually in the pedestal, just to this. I think because in the pedestal I use 3 Arduino 2560, and the pedestal I also use 2 2560 Arduino, and 2 joystick controller. Of one is Joy, and the other one is from the Throttle Tech, and the other one actually I just added lately added it to, I forgot to control the ECAM to that. Okay, because the ECAM I modified into DIY. Later I'm going to talk about ECAM in the pedestal. Anyway, this is some power terminal, 12 volt and 5 volt, just to distribute the the power into several boards. So it's another view. So it's very messy. This one is another view on the left side. So there's another power supply for the 5 volts and 12 volt for the several relay. So I use a lot of power supply here. So it's, I think, consuming around 150 watts total when it's inactive condition. This is the amplifier for the speaker. So it's quite messy. It hasn't been tidied up, and it's not covered because I just try to be able to reach easily when I need to repair. So that is the master instrument panel in general. Yeah, so this is the final look. So once it's done, you might not know that it's actually built using the plywood or a messy cabling inside it. I've actually broken to the first monitor, 2 of them, because I tried to fit in, and then I cracked, I think, the LCD or the circuit. I think it could be the circuit, it could be the flexible cable, the flat flexible cable. So I broke it, and then there's a line over there, and then this one actually not very crisp, so I replaced the Samsung one with the SPC, the newer. I got the Samsung 19-inch from long time ago, so I think it's not so good. So I replaced it with the new 19-inch monitor and the 22-inch monitor, both from the same vendor. So it has a bit more color. It's the same setup, the same electronic, but actually a different voltage of the backlit. So I recall this one is 48 volt DC backlit, PWM, of course, by the monitor, but I put another PWM. So I put the 100% strength of the brightness, but then I PWM, or dimming myself, using this control here. One of the potentiometer can actually control the dimming through a PWM circuit, so it can dim the backlit manually from here, not from the menu. So similar here, I put it on the top section of this, sorry, on the, I think on which one? I think, yeah, in the top. Yeah, the top. I forgot which one, here or this one, is a dimming potentiometer for this 19-inch monitors using PWM. This one is 35 volt DC. This one is 48 volt DC when it's max brightness. Okay, so that is the one that I control through a PWM circuit or dimming circuit. Okay, so this is the finished final panels, and except for this chrono that is not working, the rest actually working quite well. I think one of the button here is not functional because I ran out of Arduino pins, but it's rarely used anyway. But the rest of the thing is working except for the chrono, of course. So again, this one is the finished one. The file has been uploaded into the Google Drive, and in the part 3 I already put the link to my Google Drive in the description if you missed it. you can take a look in the description. Then you can find the link to the Google Drive of the 3D models, the Coreldraw source file. Okay, so that's it, and we continue next to the FCU panel. It's going to be quick because here I didn't DIY the panel actually, but just for the sake of the video, I'll explain a bit on the design. Okay, see you in the next video.